Hello, everyone. I'm Jackie, and this is Carlos. We're with Touzet Studio, and thank you for sticking around, those of you that have. I know that we're between you and happy hour, so we will try to be not fast, but at least not drag it on, so that we can wrap up this amazing experience. I just also want to echo what everybody else has said, and thanking really the ACAW team, the Boston Terracotta folks for hosting us and for providing really what amounted to be. I felt like I was in Willy Wonka's chocolate factory, going to your facilities and seeing all of the possibilities. Just really has inspired us and has educated us, and we're ready to go with terracotta. I think we've learned a lot. Our project, just like doing this right. Yeah. So just to jump into our challenge, our team was really going to be a little bit different than what you've seen today, in that we were focused on a project that could be scalable for probably one of the most banal of applications, which is a parking garage skin. So in that sense, it wasn't trying to be super specific about a one-off design, but it was really something that we could apply to multiple projects. Our background as a team, we're from Miami, and we are probably one of the smaller firms involved in this challenge. And Miami really is a concrete town, and we're witnessing. If you want to know why we're in the water category, I don't think you have to ask yourself. But a lot of people wonder if we have a future and what that's going to look like. And I think that's part of the reason that we're so interested in terracotta as a material. Concrete, as we all know, is not the best for carbon. But we love our home, and we're very proud of our heritage and our culture. Carlos and I are both Cuban. Gabby is from Brazil. We all come from different places. It's a very multicultural city. And if you think about it, Miami is known for its concrete. It's known for its sculptural shapes. It's known for its color and its playfulness. But our practice, we've been trying to deal with alternatives to concrete, or evolving concrete, if you will, to kind of deal with some of the challenges we're facing, from not just from water, but from heat and from a host of issues that I'll get into. These are some of the projects that we've done. We've been fortunate to partner with folks like Nike or Apple, that are global leaders in design and technology, and really have allowed us to kind of push facades as much as we can push them in Florida. Which, the other challenge about Florida, I should say from right off the bat, is that cost has always been historically an issue. We are not blessed with the budgets that other regions and other cities have. So one of the reasons that we're trying to look at terracotta, I think, is that now finally we just completed our first terracotta facade building on the third image. So we really think that the market is getting ready. It's more sophisticated than it had been in the past. And as a region, there is a history of terracotta. These are images from Cuba and water. And how roofs are oftentimes clad in terracotta. So there is a language and a vernacular that is terracotta, but it's not something that we see in Miami. This is an image that I took in Cuba, and actually the roofs, some of them had been recycled, which I think is an interesting idea, that they reassembled them from monasteries in Spain, brought them to the subtropics, and then reassembled. So I mean, if that doesn't speak to the durability and the appropriateness of this material in our climate with hot, humid climates, I think then nothing does. And I just realized that I did not introduce my team, and I'm going to go back, if you don't mind, because I was a little nervous. I'm with Thornton Tomasetti, Gabby and Vish, and Carlos and Jose are here from our team. Ivana is not here. And this is the team for this project, and I will go back to the presentation. Apologies. So anyway, Miami has a history of terracotta use. We discovered this facade that had been restored recently by Boston Valley Terracotta, and we were wondering, one of the reasons we joined this challenge is we were curious to see if this material, now that the budgets that seem to be increasing, there's a growing awareness that concrete is a problem from a carbon standpoint. We think that there's a real opportunity to reintroduce this material back into this market. One of the things that we loved about terracotta was that it offered us the ability to play with color, which is something that in our market is highly desirable, but that it's also strong and durable and easy to clean and maintain. I want to pause about design and beauty for a second, because we were walking with Omar and through this through this amazing tour, and we got to see the Guarantee Building. And we talked about with Mick also, he mentioned how long should a building last. And in our experience, if we're trying to convince somebody to spend money on a facade and it's out of the norm of what they normally do, if it's not concrete, stucco, and steel and metals, which is what commonly is used in metal, we really have to do something that they consider to be beautiful. And when it is beautiful, you can see that it does last because people take care of it. And I thought this was a really beautiful quote, that in the end, we conserve what we love. And so the idea that you're going to just be economical about something or functional or rational without thinking about the beauty, I think that sometimes designers feel uncomfortable with that word, but in fact, it is what keeps people wanting to invest in your project and to do a material like terracotta, because they really just fall in love with it. We couldn't get enough of this building. We have seen people fondle our terracotta. We ourselves can't stop touching it and looking at the glaze. And we think that there's a real human need for that in our built environment, aside from all the other important things that all of the teams have touched upon. This need for connection and beauty. So I feel sorry for this generation, but we think our generation needs to be about the solutions. When I graduated, our region was hit by Hurricane Andrew, and what we witnessed after that was that our wind zones have gone through the charts. We started at about 120 miles per hour, and now we're like at 150, 180 miles an hour winds. We're in what you would consider a high velocity wind zone. So one of the reasons that our design, and so grateful to work with engineers that kept us honest and really mindful, is that we cannot propose something that would fly off the building or not be engineered for these South Florida winds. So that's something I think that's unique to us as far as the teams that we've seen so far. We try to avoid systems that were too fragile or too complex or too difficult to build for that reason as well, because our contractor base and our clients would be very concerned about something that looked like it could fall off the building and fly and become a projectile. So that's something that we had to deal with. And this is where we are right now. We only have maybe 2 tiles that we can specify that are concrete. And what we're witnessing in the market is that facades are delaminating. So mortar beds are not holding up. We're getting what used to be 100, 500-year storm doesn't mean anything. And when you couple it with wind, it's really an issue. It used to be that we would mud set stone facades. Now we almost always mechanically fasten. It is now the code requirement that you mechanically fasten. So we were really pleased that Boston Terracotta has a system that's already has an NOA, because that already, if you have to tell a client, hey, I have this material you've really never used before, and you're going to have to engineer it, and we're going to have to get it tested, that it becomes just another barrier to be using. We talked about water. We feel like water, there's an open question about whether or not people should even build near the water, and I'm not going to get into that. All I will say is that, I don't know, my people have been in the region since the 1600s in Cuba and in that area. And if we cannot, with our ingenuity and our innovation and our resources, come up with solutions, then what hope is there for the whole region? Not everyone has the resources to move. And if you look at that map that I showed you, this was a little graphic that the New York Times did. I think the whole world is under threat, right? And our little corner of the world has hurricanes, and we've got extreme heat everywhere, and we've got flooding. But I think the world is going to start looking a lot more like Miami, where we have to deal with extreme heat, humidity, rain, and flooding. So we have to engage with that reality. And the other part of this water is that it's coming from the ground for us, because our ground is porous. So in looking at historic buildings that were using terracotta and that were using materials like that in the 20s, it's interesting to see that the reason that the base of the buildings were made of materials that could be easily wiped and cleaned is because when you have flooding, you don't want things to grow on that facade. In fact, you want to be able to clean them off and hose them off, because the stuff that comes with flooding is not nice. It is really a toxic brew and stew. So we're looking at materials, when we say durable, we don't just mean that they can stand with wind and they can stand with extreme heat, but that if the water rises, and it will rise, what's left behind, we can clean it off and continue occupying these buildings. So that's kind of the brief, and that's why we were interested in terracotta. We think it has a lot of the qualities that we need without the carbon. This is just an example of a project we were playing around with fiber reinforced concrete, and one of the reasons that we tried to get this client, in partnership with us, to change from a dark metal skin is that in our climate, keeping it light, as you guys have heard over and over again, is super important. Keeping it non-porous also important. So this fiber reinforced concrete was interesting. So we had all of these, we're finding that metals discolor a great deal. It's not great to have a lot of metal in our buildings in our region. And so this had a lot of positives, but the negative that we found was that even though we were able to reduce the amount of material by using fiber reinforced concrete, what we ended up with our wind codes was a giant metal armature. So if we're being honest with each other, I don't need to do a life cycle analysis to know that that's not a carbon, necessarily a carbon friendly situation. We do a lot of adaptive reuse because obviously everyone knows this, but the greenest building is the one that exists. And the reason we ended up with this, I just wanted to show this project because it's the only other terracotta project that we've done. And it was a garage skinning. And it was an existing garage from the 1980s. It looked like that. And this question of what do we do with this aging infrastructure and in the future is an interesting one. It was reclad with, we decided to reclad it, and we convinced the client to use a terracotta skin. Which ended up looking like that. It was a really good and instructive lesson for us. It was almost VE'd out, but we managed to keep it by spacing it out and using less of the material and using a consistent palette. In this case, again, trying to always look at Florida-friendly or Florida-inspired materials. We were looking at seashells because there was a question, is this going to be embraced by the community? Are they going to feel like terracotta is an appropriate skin? We had a brick building in our foreground, and the name of the client was actually Terra, so we felt like terracotta was a good bet. So we were able to get it in, and it was well received, and it did install beautifully. And they will not have to paint it, and they will not discolor the color. This isn't Boston Valley, but we didn't know you guys then. I apologize, but I wanted to. But it did win awards, and it is on the cover this month, Florida Architecture magazine. So I do think there is a possibility of using more of it, and we just have to figure out how to make it such that it doesn't get on the cutting room floor because of budget. So this project was the one that we chose to study. It's again a parking garage structure on the river, and the inspiration for what we call the water wall. Although we also kind of workshop blue wave, but no, that has political meaning. There used to be in Miami, there was a river, and it used to have rapids, and that is no longer the case. Now it's gotten much more built and so on. But there was this memory, and our site is on this river. So we have designed a building that we presented to the city and have an approval on. And there was this idea of doing, one of the things about new buildings and new construction in Miami is that any new building has to take care of their water on site. I think the group from New Orleans talked about that. So when you have all of this new construction next to lower density buildings, you have to take the water from the roofs, somehow deal with it, hold it, and release it slowly so you don't flood your properties next to you. So the facade that we were looking at was this one, where we would take the runoff from the roof, sort of let it slow it down, and then bring it into cisterns and into a rain garden at the base of it. And this facade was in metal, but we're also now looking at it as possibly terracotta. But for the purposes of the exercise, we were looking at this one. We have one precedent where this is important, though, that we've ever seen that had done something like this, where they have the storm drains from the roof, but they also let the water kind of slow it down with these series of terrace of planters. It was good to also show, whenever we try to do something like this, to a client of something that exists in the world, even if it was an expo, because it kind of suggests that that's a possibility. So this is one that we were looking at. But if you think about all the terracotta facades that we've seen, even historically, they managed to take all of those elements and make them beautiful. And terracotta is a material that could handle each and every one of those components, from the scupper to the planter to everything really about it. But for our purposes of ACAW, we decided to just deal with the cladding. And we had to kind of pick a spot because there were so many opportunities, I think, like everyone in this challenge. So I'm going to let Carlos get into the evolution of it, but this is kind of what we settled on. So this, just to explain it really quick, this would be the base. I mean, if you extrapolate this up, it would be kind of, here's a view through. And that's a whole study of how much material we needed. This is the original sketch that we presented. But the idea was that we were going to do the facing of the planter, and then an
So I just wanted to mention that because there is so much water coming off of the tower roof, but it's also coming off of the vertical elevation towards the east, because these are very deep balconies for marketing. So the floor to floor is almost the width of those balconies. So those balconies are picking up huge amounts of water. So before we were awarded ACAW, what we had been doing was to bring down all the water from the eastern facade of the tower and the roof, taking part of them into cisterns on the landscape deck to be able to use for irrigation. And then we also had substantial planting on that roof to be able to control the water coming into it. So all of these things become temporary holding basins for the water so that we're not flooding the street. The roof deck itself still was generating water. So that's why we ended up with this green wall where we would be taking portions of the rest of the water valved, channeled, and then really controlling it, taking it through the planters and bringing it down. The idea with the terracotta immediately became, let's do something that actually brings it to the forefront. Here we're collecting all this water. We're showing you that you have to do this. So let's just celebrate it. Let's take the opportunity to use the terracotta as a way of not only playing with the rainwater that hits the surface, but that as we bring the waters down into the planters, there's a secondary piping system that also starts to drop it into the terracotta. So it really ends up being the situation where not only while it's raining, but after it's raining, that you have this kind of play of water, which in a way is an allusion to the only cascading water that ever existed in South Florida. And we went through a series of initial design tests. We really needed them to be curvilinear shapes. Just aesthetically, we thought it would work. But we knew really early on that all the shapes really had to be extruded to keep the cost down. And the final scheme, this is an early iteration of how we would be running it. This is starting, the one in the middle is starting to get closer to what we ended up planning for the building itself, which is there are two extruded shapes and then one cast piece for the top, which I think will end up as also an extruded shape. And then I'm going to pass it on to you.
So once we started looking into the constraints of this project, right, we understood that we had 10-foot bay, 8 to 10-foot bay structural grid to deal with. So our system would have to spend that much. We would also be dealing with a system that would be collecting water and working on the retention of this water, and would have to sustain high wind loads, hurricanes. So we are also looking into having some type of secondary retention framing system. So once the pieces break, they could be retained in place and do not start flying around during a hurricane event. So we started looking into that, and it also needed to be a cost-efficient system and competitive to go through the project itself. So we knew immediately that pressing and slip cast was not an option for us because of cost. We had to explore extrusions. We also wanted to do repetitions, not only in every bay, but also within the bay. We wanted just one unique die. We wanted to explore extended attachments. They are already widely used in the industry. We didn't want anything custom because that would also add costs. And we wanted to also work with Boston Valley on the fabrication and then installation. So we did a few design intents, which we have discussed, and our third evaluation was actually what we went through. I'm going to walk you through all the processes we did. The first extrusion, we thought, well, we extrude one piece, we divide them into two. We have two pieces to play with. We could deal with one side curvature. Towever, once looking at it from the inside, we were not meeting the design intent. So it looked flat. It didn't carry the movement Touzet was looking for. And also, we started to see that we could not manage the water flow on the inside. So immediately we wanted to go into a system that could carry curvature on the inside and on the outside. And that was one of our iterations. We did see that having a channel was also not working well because you would accumulate water at the location. So we did another iteration where we closed the extrusions, but we did want to span 10 feet. So that's where we had to add aluminum extrusions to it. And then we came back to the same problem of looking to the inside. If you look to the inside, you're going to see extrusions, not meeting the design intent again. And with this scheme, we would have unique attachment points. And we also wanted something that would be sustainable. So adding metal was not an option for us. So our last and final iteration was to add a supporting point at mid-span, which brought the system and the extrusion lens to something typical and done that Boston Valley has done multiple times. So we'd be dealing with something that instead of spanning 10 feet, would now span 5 feet. And guess what? All the standard systems that they use for TerraClad would be sufficient and implemented and widely applicable. And we've seen multiple installations, easy to install, easy to fabricate, and beautiful. So that's just to show the inspiration and how we got to our extrusion itself. We need to fine tune how we would have the inserts that would go and span the 4 feet, not the 5 feet anymore, or not the 10 feet anymore. We also had to modify the acute angles to just avoid stress concentrations, and we had to include a landing zone so it could be extruded in the plant. Then finally, we had the big scale project design, but we had to shrink down to fit the mock-up, right? So our base went from 5 feet to 48 inches. If you looked at the design intent, we initially carried 3 extrusions, 4 extrusions, and then we modified 3 extrusions. And then we also included coping piece to give this movement. And then we're gonna get
So I think that this one we learned from our cohort here, the embrace the imperfection, which this Arab I think said it. The way we look at it is to celebrate the variation, which I think is a similar thing. But in terms of selling it maybe to a client, you know, the imperfection thing, they may not understand that. The closer we got to using what the material can do, and Andy, thank you so much for where is he? The glaze was so much of what made it so beautiful for us was to see how the glaze reacted to the shapes and to really use light and how we position these things in space creates the shadow play, and it's, you know, accentuates what we wanted it to do. From the get-go, we couldn't stop touching it. People kept coming over, and you know, and it is a delight. And architecture, as we said, is part of that. So there are just so many moments and people would see all sorts of things in the glaze, you know, micro, macros. So it's great. So and the little puddles and the rivulets that formed actually look like the little the sea foam or the water froth that we were kind of looking for. And so this kind of accumulation of the glaze in the center. And those drops, they really look like, you know, rivulets. So it really kind of brought to life a concept that we had in our minds about a waterfall into. And so, you know, the ultimate test was to put water on it. And as soon as we took it outside, I want to say 2 bees came over. So I think, and I'll say the planter is in metal. It could be obviously terracotta. And it's just that we didn't go that far because that would have been another component, and we didn't want to be. How do I play it? Yeah, you can see how it plays. It's like a rain dance that happens. It was really quite beautiful to see it in the sunlight and to see it with the rain. And we're big believers in bringing biodiversity and pollinators back wherever we can. So we do a lot of green roofs, and we're big on vegetated facades. And so it was fun to add that component. Clearly, that's a whole study, as you guys have seen with a lot of the teams that have gone full into it. And we were just kind of playing with the angles to create the effect over the course of the facade, but there's a lot more study that can go into the precise angles. We did speak to our landscape architect consultant for the job as to how high the plants would want to have that dripping and how they would tolerate that. But there's a lot more study to be done for that life to be sustained. But we think it's an important goal to try to bring it every time that we can. So yeah, this little rainbow happens. You know, it's just nature. That layer of light and rain and nature is what gives all of it life. And we really wanted to do the most with the least, or as much as we could scale it up and to study for ourselves with a lot of constraints what we could do. And because it is such an amazing material, and Andy again, it really, we were super happy with how it turned out. So what we learned from our perspective, for what we wanted to learn about this, it is, you know, that saying from Picasso, learn the rules like a pro so you can break them like an artist. This is for us about learning the rules. And now we know we could add more texture and it wouldn't bust the budget. We could, you know, do with some things and it wouldn't. And we know that the span and the size of the fins are about right to kind of maximize the material. And probably the depth would throw it off. So we would have to play around with that. So we're kind of like tweaking. How do we get to a place where we actually can present it to our client and say, we've got a really good alternative to metal or concrete. And we think you should consider it. And I think we're very close to being there. And we have another job that we're looking at, extrusions, that and I think because the market is getting more sophisticated and the budgets are big enough to absorb a better skin. We're in our region, at least, we're starting to see that this is a material that needs to be reintroduced. Our job is to try to understand it well enough to sort of make the case for it. So I hope that was informative to you guys. Thank you for your.
Okay, questions?
Hi, thank you for this presentation. It was amazing. And as you said, the minute I laid my eyes on it, I just wanted to touch it. But I have a question regarding acoustics. I'm sure you acoustics. You probably thought about this, but thinking about it as a whole facade within a parking lot.
Mm-hmm.
Did you think about the acoustics when looking at the form? Because I'm sure it's going to be louder, probably.
That's a really good question. We thought about the show, and when we get rain, it's like a thunderous rain, but it's usually like a short, brief rain, and then it goes away. So no, but I think that's an interesting question. We work in a studio where we get rained on, and we're in the heart of Little Havana, and when it happens, it's kind of like, yeah, it's raining. You know, here it's a thundering rain. But that's an interesting question. People usually in a parking garage pass through, so it's not like an occupational, like you'd be annoyed by it because you're sitting there for a very long time. But I don't know. We thought it would be cool if it did. Go ahead. One question.
So I wanted to mention that actually the terracotta pieces in the real garage would be much further apart than this.
Yeah.
And the other wall, the main wall, which is I think a ratio of probably 3 times the width of this elevation. Originally, in the image, it looks like it's metal, but it's tubular metal with a fabric.
Mm.
So that elevation is very, very open. The intention being that we're able to bring in enough air through it that it'll be a pleasant space. But that is really a concern. Garages can be loud and horrible.
Yeah.
Thank you.
You get to the other side there.
Yeah, thanks for the presentation. It was really interesting, and the colors are stunning, and especially the way the light works. I was just wondering, in terms of like locality and fine tuning a building, and I was wondering if any thought had been given to the adjustability of the panels, either over time or in its initial installation.
I think that one of the reasons that we like the idea of not mortar setting in Miami anymore, and the idea of fabricating things that can be disassembled is, to your point, if we ever need to relocate a facade, you know, in the future, I think if we're talking about buildings that can last, as Mick was asking us, how long should a building last? Well, if you're building in a place that's under threat, maybe you should be thinking of disassembling and reassembling. So this has that potential. We didn't study in this particular installation, but the fact that we're not mortaring anything into the facade is already an improvement over how most of the skins get applied, like, especially on the front face where we did the planter. In terms of adjustability, that's always an issue with wind zones. If we're trying to make something move, it tends to get a little trickier with the high velocity winds. Typically, our engineers kind of want to keep everything where it is because of that issue that we have. It is, I will say, one of our biggest challenges is doing things that are robust enough not to fly away, and they have to actually sign and seal documents saying that nothing's going to do that. So if you move it, buildings that can adapt to the light, and unfortunately, we almost always have to not be able to execute them that they operate because of this issue of the hurricane winds. So
I don't think I have a picture of the real connection itself, but it's a very simple system that could be just unscrewed and lift off. I mean, the pieces are quite heavy. You need a few people to lift them, but it's very easy to assemble and disassemble the system.
that was, yeah, one thing that we learned from assembling this, by the way, which was really instructive for an architect to have to install the thing. I don't know how you guys felt about it, but I have we always have been very respectful of people that build our buildings, but now I have a lot more compassion for the weight aspect of this, and we're all about maximizing, but then, somebody, especially in our climate, has to get in the hot sun and build this thing. And so I'm not joking around when I say that this was like, wow, we really need to make this lighter so that two people could do this quickly and not be like, if I showed you those photos, there were 3 or 4 of us. And, as job sites heat up and it becomes ever more of an issue, I mean, it's a thing, so I was really happy that it's so easy to install, but the weight of it and the complexity is certainly something to think about.
I just quickly wanted to ask about, and I know you showed this, the load path, the hierarchy of that, but because these are so stiff, now so curved, so they've got even more depth and they're super stiff, have you considered it as part of the structural system?
Well, we could have. The thing is, if you want to consider that into, so pretty much our system, right? So pretty much the system consider the splines, right? And one of the beauty of the splines is that we don't have to deal with any anchorage straight into the terracotta itself. So we thought it was really reasonable to have that. And plus the whole, like how easy it is to assemble like those brackets with these infills. So we could have considered the terracotta itself bending and do all the studies where you actually need reinforcement. But this system is so simple that wouldn't have made sense.
And I would also just want to add, Marilyn's already ready for you. Go for it.
Any other questions? Great, thank you very much.